All right, let's now look at the side angle side condition. We looked at it in the Euclidean geometry and hyperbolic geometry. How about spherical geometry? So let's just remind ourselves quickly what a triangle is going to look like in spherical geometry. Let's do that first. So in spherical geometry, the plane is a Euclidean sphere of radius 1, and these are points on there, and you can see the line segments. These can't be antipodal points, or you don't make line segments like the North Pole and the South Pole. But as long as they're not that far apart, you can make line segments and you can make triangles there. Notice that the sum of the angle measures in this case is larger than pi, larger than 180 degrees. And you can see how much over it is here. Okay, so let's investigate this. Let's look at side angle side. And again, I want to open this in the app. Okay, so once again, this works just like the last two examples. We start by having a line segment there, and we can specify its length. Okay, and then we can pick B anywhere on that circle. So now we have vertices A and B. Now what happens next? Well, we pick an angle. Angles will go all the way from one point to their antipodal point, like from the North Pole to South Pole, and that will give you Euclidean-wise, that's a semicircle, including the endpoints of what we call a great, not just any semicircle, but what we call a great circle. As a Euclidean object, the center of this is at the center of the sphere. Okay, so anyway, we have that. That measures this angle right here. Okay, and so then when we go out the next one, we see that that has to be the same distance there. So we can go out, doesn't matter where we pick that distance or where we pick this distance or what we pick for this angle. If you notice, it always can be done. So there's not a zero congruence class possibility. There's not an impossible possibility. There's no measurements that make it impossible. There's always possible to make a triangle with any given measurements. And when you do make one, all of them have to be congruent. So the situation, as we see it, turns out to be exactly the same in Euclidean, hyperbolic, and spherical geometries. How about taxicab geometry? Let's look at that next.